Now we have wall detection working. We can see when we're up against a wall, but we still get stuck and we don't use it. So before we go on to the solution, I want to do this as a challenge and give you the opportunity to take a look at what we've done, take a look at our two new parameters and maybe our update movement method, and see if you can figure out how to stop the player from running up against walls or sliding down against walls and kind of holding themselves up against them. So go ahead and take a look, see if you can figure it out. You could do it in as little as 4 lines of code, maybe even less, and it should be a relatively simple one. If you get stuck though, don't worry, we're going to go through the solution in just a second. So go ahead now and give it a try. All right, I'll assume that you've either done it, had lots of success, or maybe got a little bit stuck and had a question or two, and we're going to go through the solution right now. So let's open up our player script, and inside of our update movement method, right here, we're going to do a check right down at the bottom. Before we set the velocity of our character, we're going to check to make sure that we're not trying to push up against a wall. If we are, then we just won't modify our horizontal, or we'll set our horizontal to 0 to stop ourselves from moving. To do that, we'll add in a couple lines right here on 191. We'll say if our desired horizontal is greater than 0, so if we're going to the right, and is touching right wall, then our velocity, or our horizontal, not our velocity, is equal to 0. Now, it will also want to do the same for the left, so I'll just copy this, hit enter, and then do a check for negative or less than 0. So if desired horizontal is less than 0, meaning we're going to the left, and is touching the left wall is true, then horizontal will also be set to 0. Now if I save, go back into Unity and press play, I should see that I've got nice smooth movement with my character, and I can no longer get stuck on those walls, and I should actually stop running when I push up against it. Let's see if that's the case. So I run over here, my character stops trying to run, and if I run or jump and slide down these edges, you see that I can no longer get stuck and act weird, which is going to be perfect for our bee encounter. So once we get over here to start fighting the bee, well, this is where we'll see that our raycast actually needs to be slightly smarter. Remember, we used a very basic raycast, and it's checking against this trigger and thinking that we're touching a wall right there. In fact, when we're in the water, it thinks that we're touching walls on the right and left. So we've refactored this code and split it up enough that it should be an easy one for you to fix. So challenge number 2, go fix that. Go find the problem, see if you can figure out why it's getting stuck, and if you can figure out the solution. It's in the raycast. It should be pretty straightforward, but if you get stuck, don't worry. We're going to go through the solution in 1 second. All right, back to it. Let's go through the solution for our raycast. So when we check if we're touching a wall, let's go find the code for wall touching. Update wall touching right here in our check for wall method. When we do this check, we're just doing a basic raycast right here on line 115. Now this has 2 problems. 1, it checks triggers, which we don't want it to do. And 2, it only checks 1 object. So if the first thing that we found was a trigger and then we had another collider there, then we could end up in a scenario where we're up against a wall, but we don't know it. So we need to make a quick couple changes to our raycast. Let's go find the part where we do our grounding. In our grounding, if we check our check grounding method, remember we call raycast with the results, where we pass in an array and then we fill it up and then we get back a number of hits. Let's copy that, lines 222 through 226. And then we'll go back into our raycast here, and instead of just doing 1 raycast, we'll raycast against all of the objects. I'm going to tab this over here, and then we'll use the direction instead of vector2.down. And then for our layer mask, I think we can use that same layer mask and we can use the same result. Now I'm going to delete lines 120 and 121, and instead we're going to loop through all of our results. So we'll do another for loop, and we'll loop through to the count of hits. And notice that I'm reusing results here. That's totally fine. These aren't running at the same time. Results will get cleared out and reused. It's totally fine to reuse it for these objects as long as I don't have to worry about them happening simultaneously. So here we've got an issue where it doesn't like my loop inside of a loop because the variable name is the same. So we're going to rename I to the next letter in the alphabet, which is J. So we'll loop through J hits and we'll check to see if any of the objects that we hit are not a trigger. If they're not a trigger, then we'll return true. So we'll say if, and we want here our results at I dot collider is not equal to null. So we'll do question mark dot is trigger equals false, double equals false. So what that's going to do is double check that there is a collider there is true and the is trigger is there and that's equal to false. If that's the case, then we'll return true. I don't like that this is a little bit confusing to read though, so I'm going to just rewrite this. Let's say var hit equals underscore results at I, and then we'll say if hit dot collider and hit dot is trigger or hit dot collider dot is trigger is equal to false, then we'll return true. Again, does exactly the same thing. I just feel like this is a little bit easier for me to read and catch that I used results I here instead of J. Exactly the kind of thing why I want to split this out. In fact, let's call this hit index. And I like that even better so that I don't have to worry about accidentally using the wrong variable there. All right, so now we're looping through all of them and only checking colliders. That should get us much closer to working. Let's see, I can run around. I've got my touching is working. I can jump, it's looking good. I'm seeing an issue with my grounding though. I think that's the last thing that we're gonna wanna check out, but let's go jump along and make sure that we slide down these things. I jump and I slide, but I am seeing that even when I'm jumping, it's saying that I'm grounded. And I think that the likelihood there is that it's finding our collider because in our current grounding code, if I go back in, we check right here, and I bet you anything that this raycast right here is hitting with our player's collider and causing us to show as grounded as well. So let's stop playing, fix that final issue, and then I think we will be good with a nice smooth player. So let's get our player character over here again, and then in our is grounded code, in our check grounding, we'll just do a tiny offset on the origin. So instead of doing it right at the edge of our collider, which is, let's see, check grounding, we got our origin, and our origin comes from right here, which is our sprite renderer's bounds.extents, which actually is probably the issue, is that we're using the sprite renderer instead of the collider. So let's do a quick change to our check grounding method as well to use the extents, and maybe let's just do an offset instead of using a variable here, so that way we can modify it and customize it just like we do with the wall detection offset. So I'll call this ground detection offset. And we'll replace that in all three of these instances for the Y value of the sprite renderer so that we can now customize this. We'll generate a field, hit F12, and then make this a serialized field. Oh, I did not spell serialized field at all. There we go. And then we'll move that up by our other serialized fields, right by the wall detection distance. We'll have this be I think I'll move it right above. Let's call this ground detection distance. I like that better. No, I like offset better, now that I think about it. And we're going to give this a value of 0.5 so that it's right from the center of the character. I think that that's what I want to use. We'll make sure that we're not in debug mode. Jump back into the editor. We should be able to now see that variable. Actually, let's go make sure that our gizmo is set up too. On draw gizmos. We've got our origin here. We're doing the same. We need to do the same offset. So we'll do this as the ground detection offset. And we'll paste that in for these other two fields as well. Or these other two instances of it where we're calculating our origin. All right, we'll save. That's also a great opportunity for refactoring because we're now duplicating that code. Having to update it in two spots means that we probably should be refactoring it and changing it out, which will come very soon. All right, so now we've got our offsets. Let's go check the ground detection offset. If we set this to 0, let's see, drag it down, get the lines right there. I guess we're looking at about a value of 1, maybe a 1.01, just to be right below the ground. We'll press play. And now let's run over there and jump into the area, and I can get into the trigger. I can move around and make sure that my jumps are not infinite. Just got my double jump, and I can slip down the sides of these little pieces. Everything is looking pretty good so far. The last thing that we're going to need to deal with, though, is right here. If we get into our water and jump, watch what happens. Once we come back down and try to land again, we can't jump anymore. And the reason for this and fix are both very simple. What's going on is inside of our check grounding, let's open up that player script, we replaced our raycast with this raycast that checks against multiple objects so that we could find multiple things on the ground, including triggers down there. But when we do this conversion, we're using the raycast that fills out a bunch of results here, and we pass in a contact filter 2D. Let's go take a look at the contact filter 2D by hitting F12. The default value for whether or not it should use triggers is going to be false. And that's because we've got a bool here that's not assigned to true by default. And our struct doesn't have our struct does have a constructor for no filter, but it doesn't have one as just a default constructor that is going to put that value to be true. Let's just go triple check that though. So if we go back into our contact filter and we search for use triggers here, we should be able to find the spots where use triggers is set to true, which is, let's see, create legacy filter. There was one spot up above in the unfiltered. There it is. Oh, oops, I missed it. Create legacy filter. Oh, and no filter right here. So that's not what we want to use. We want to make sure that use triggers is actually set to true. We don't want to do no filter, and we don't want to use one of the legacy ones. So we'll just go back and we'll add in that parameter to our contact filter right here. So after the layer mask, say use triggers equals true. Save, and now if we go back into Unity, we should be able to jump in water just like we were jumping in water earlier. Let's go make sure that everything is good, and then we'll do our commit. So we play. All right, jump. Let's go test the wall first. Looks good. We'll go into the water. Jump, jump. Water, jump, jump. Looking good. And then we'll go over here to the fight, and this all looks right too. I can move around. Everything is going exactly how I expect it to. So we'll stop playing, and we'll go into Plastic and commit our changes. Message here. Let's put fixed player movement. Kind of encompasses everything that we've got in there.